In these examples, I will be talking about some questions that you see in section 1.8, and that is composition of functions and combination of functions, which are two different things. Now, it is talking about functions, and let me start with composition of functions. Let's just say that you have two functions. One of them is f of x, and it's equal to 2x minus 1, and the other function, let's just call it g of x, and let's say that that is equal to x squared. If I ask you, what is f of negative 2, it simply means to take the negative 2 and substitute it into f of x. That is, substitute negative 2 into x. And if you simplify that, you get negative 5. As another example, if I ask you to find g of negative 2, it means to substitute the negative 2 into x that is part of g of x. And so you would square negative 2 squared, and you would get 4. So g of negative 2 is equal to 4. If I ask you to find f of the input p, now p is not a number, but I would do it the same way as I did previously. I would plug in the p into f of x, and I would get 2p minus 1. I would just make sure that it's fully simplified, and that is it. As another example, let's say that I ask you to find f of g of x. Well, in this case, it wants you to substitute the whole expression that is g of x into f. Another way of that you're going to see that same question written would be parentheses, f, followed by a little circle, followed by g, and parentheses, and x in parentheses following that. That is saying the same thing as before, f of g of x. You sort of read it backwards. You take g and you put it into f. So if we do that, we take g, which is x squared, and plug it into x in f of x. And so after we simplify, we get 2x squared minus 1, and that would be the answer. Another example, or a similar example, would be that I ask you to find g of f of x. Now, if I write it in the function notation, I would say g of f in parentheses, and followed by x afterwards. And that is saying take f and substitute it into g. So in this case, we would get 2x minus 1 in parentheses squared, and the answer would be we would have to FOIL. And if we FOIL, we get 4x squared minus 4x plus 1. Now, if x is actually a value of a number, if it has a value, for example, negative 3, and I ask you to find g of f of negative 3, that can also be written as this other way. It means the same thing, though. We would start with a negative 3, plug it into f, and figure that out. And so we would find that f of negative 3 is equal to negative 7. After that, we take that negative 7 and substitute it into g. And we would get negative 7 squared, which is 49, and that would be the answer to that. Now, let me go on to the next set of examples, and that is combination. This is the next topic, the next idea. Just like before, just like composition of functions, I'm going to let I'm going to give you two functions, f of x and g of x. However, the operations will be different. So in the first example, if I ask you to find, to combine the two functions f and g by adding them, the notation will look a little bit different. Sometimes you'll see it as stated as it is on the left side. Sometimes you'll see it stated as it is on the right side, but they mean the same thing. So if I ask you to add them, you would simply take both expressions, f of x, which is 2x minus 1, and add it to x squared, and just simplify. And that would be the answer. Now, part B, if I ask you to find f, or the combination of f plus g of negative 3, the way to do this would be to find f of negative 3 and then add it to g of negative 3. There's actually two different ways of doing it. This is one way. F of negative 3 is negative 7. G of negative 3 is positive 9. So if you add those two functions at that given input of negative 3, we would get negative 7 plus 9 is equal to 2. Now I said that this was one way of doing it. Another way that we could have done it was to substitute in the negative 3 in the same expression that we got in question A. But if you don't have that work already done, then this way would be one way. Either way would work. Now question C. That says that combine f and g as a product. Multiply f and g. And you would get f, the expression for f, 2x minus 1, and multiply it times the expression for g, which is x squared. We would simplify by distributing, and we would get 2x cubed minus x squared. Nothing else to do. It's fully simplified. That is the answer. As another example, if I ask you to find the combination of the product of f and g of negative 3, we could find, we could substitute negative 3 into the expression for c and get the answer. That would be one way of doing it. Another way would be to plug in the negative 3 into f, and then separately into g, and then multiply those two products. And I'll show you now. And if you simplify, you would get the same answer, negative 63. Okay, another example, I'll do quotient division, the combination of g and f as a quotient. So to do that, we would just simply write g, the expression for g on top, and the over the expression of f on the bottom. And for these, for the times where we get fractions like this, it's also common to say that to state the domain, because not everything's going to work. Not every input of x is going to make sense for a fraction like this. So a lot of the times, in combination with an answer of a fraction like this, we would also have to state that the domain would be all reals except x cannot equal to the number 1/2. In this case, 1/2. The value of x equal 1/2 in the expression below, in the denominator, would make the denominator equal to 0, which we can't have. Anyways, that is the difference between composition and combination. And that is all.